All right, talk about equality of two matrices. It's pretty self-explanatory once we go over it. All right, take a look at that at the top of your page. It says find x and y such that the following is true. Those are equal. If you have equal matrices, if there's a 2 here, there's got to be a 2 here. That's got to match up. If there's a 3 here, there's got to be a 3 here. Okay, basically they got to be the same number in the same spot. So using that fact, what can I do to figure out x and y? Okay, what can you list? What was that? Zach?
X plus y equals 4.
X plus y has to equal 4. This is that first slot right there. That has to add together to equal 4. So using that fact, x minus y has to equal 1. Okay, that's it. Same spots have to be equal. So x plus y equals 4, x minus y equals 1. Now you got to figure out what x and y are. All right, take a second, think about it. Because it doesn't just say x is 2 and y is 1. I mean, you got to do a little bit of work after that. But what is that work? All right, Chris, did it hit you yet?
Nope.
No, just kind of sitting out there.
Yeah.
Oh. All right, Sydney, hit you yet?
We do elimination
You can.
and cancel out the lines.
Sure, that sounds good. You got a 2x2 system. You got 2 equations. You got 2 variables. You can solve them by substitution or elimination. So if I'm just going to put the x minus y equals 1 underneath here. Add those together. The y's cancel out. I get 2x equals 5. Divide by 2. You get x equals 5/2. Okay. And now you can use either equation. I'm just going to use the x plus y equals 4. Plug in x is 5/2. Go ahead and figure out what y is. And so subtract, or I let 5/2 go in for x. 5/2 plus y equals 4. Oh, I hear the calculator's out. And Liz, let me know what you get.
Three over 2.
3 over 2. 3/2, 1.5, however you want to write it. So 5/2 or 2.5, 3/2, 1.5, because those two add together give us 4. X minus y gives us 1. So if you have equal matrices, basically same number has to be in the same spot. To do the following, to add or subtract, they got to have the same dimensions. Talked about the dimensions before. That is the number of rows and number of columns. So one is a 3x2, the other one has to be a 3x2 to add together. One's a 4x5, the other one has to be a 4x5. Basically, you add or subtract the corresponding elements, exactly what you would think. To multiply a matrix by a constant, take the constant times every term in the matrix. Okay, not the first, not the second, all of them. Okay. All right, so you should have 2 matrices up there, or down below there. These are 2x3s, okay, 2 rows, 3 columns. Okay. 2 rows, 3 columns. All right, for part A, it just says, what's 4A? Just take 4 and multiply by each element of matrix A. And so that's going to give me 4 times 2 is 8. 4 times -4 is -16. 4 times 5 is 20. 4 times -3 is -12. 28, -4. A plus B. Add them together. All right, I'm going to actually write this one out. I don't know why, but I am. So A is 2, -4, 5. -3, 7, -1 for the second row, plus -6, -2, 10, 8, 0, 4. Adding those together, 2 plus negative 6 is negative 4. And just corresponding elements, negative 4 plus negative 2 is negative 6. 5 plus 10 is 15. Negative 3 plus 8 is 5. 7 plus 0 is 7. And looks like get a 3. All right. Everything good there? All right, so for the third one, okay, take a look at this one. We're going to do 3b minus 2a. 3 times matrix B minus 2 times matrix A. And I'm going to write that one out too, just the beginning one. So 3 goes in front of B, and that's negative 6, negative 2, 10, 8, 0, 4, minus 2 times A, which is 2, negative 4, 5, negative 3, 7, negative 1. Distribute the 3. That's no issue there. So I get negative 18, negative 6, 30, 24, 0, 12. Okay, here's what you got to watch. You can either distribute 2 or you can distribute negative 2. Okay, some people do one way, some people do the other. If you distribute a negative 2, what sign now goes here in between them? You got to make it a plus. Okay, so a lot of people will distribute the negative 2 and put the minus sign down there. You're going to get it wrong. If you distribute the 2, which is what I'm going to do, so I'm going to basically treat it as 2 times that with a minus in front of it. So I'm going to put minus here. And then 2 times 2 is 4. 2 times negative 4 is negative 8. I get a 10. I get negative 6. I get 14. And I get negative 2. I don't care. It's like one way is not wrong, better than the other. But some people just distribute negative 2 and then they subtract everything again. So it's like undoing what you just did. So now if you did it this way, subtract, and then I end up with negative 22. Negative 6 minus negative 8 becomes negative 6 plus 8, which is 2. 30 minus 10 is 20. 24 minus negative 6 is 30. 0 minus 14 is negative 14. And then 12 minus negative 2 gives me positive 14. Okay. So just watch that. That is one case where I do see that mistake come up fairly often. So that is 3b minus 2a. All right, now at the bottom of your paper, just some properties pretty much hold similar to real numbers. The commutative property holds if these are matrices. Associative property holds. That's the additive identity is the third one. Additive inverse, and then if we use constants in front, distributive property holds and all that. All right, go ahead and flip it over on the back. All right, we're just going to do that top one here. It says solve the matrix equation for 3a plus 2x equals 4b. I'm going to go ahead and write this out, this matrix equation. I'm going to substitute in the matrices for a and b. So it's going to say 3, a is 2, 0, 4, 6. And just put in plus 2x. Okay, just keep x. That'll represent a matrix. Equals 4b, which is 1, 3, 5, 2. And go ahead and distribute your 3 and distribute your 4. Go ahead and do that. I get 6, 0, 12, 18, plus 2x equals 4, 12, 20, and 8. Just like in an equation, we want to get that 2x by itself. So what do I want to do this matrix here? Not yet, not yet. I got, yes, let's subtract that over. Now, I'm not going to do it, I'm not going to subtract it underneath it, I'm just going to do it beside it. I'm just going to write down what it's going to look like. So it's going to be 2x equals, and then this matrix 4, 12, 20, and then 8 minus 6, 0, 12, and 18. And then go ahead and subtract it. So 2x equals 4 minus 6 is negative 2. 12 minus 0 is 12. 20 minus 12 is 8. 8 minus 18 is negative 10. All right, you normally divide by 2. Really haven't divided, we can multiply by the inverse, the same as dividing. So instead of dividing by 2, I'm multiplying by 1/2. Multiply the left by 1/2, it just leaves you x times, and then 1/2 is now a constant which we can distribute to everything. And I end up with x equals negative 1, 6, 4 down here, negative 5. Okay, for that. All right, at least wanted to get some of it started today. We'll finish up the rest tomorrow. Make sure you have those notes with you.
That's good.